Okay, we are back with some quick math. You asked for the question on nature of roots. This video is going to be on nature of roots. We're going to do introduction first, and maybe in the next question, in the next video, we'll answer the questions that you actually had. I know you guys are studying very hard. Good luck in your exam preparations. Good luck with your paper tomorrow. I'm sure you're going to give me great results. Like the videos, subscribe to the channel, drop a comment if there's something that you didn't understand or need me to re-explain. The three pictures that I put on the screen there, that's basically the three options that you have. Okay, so maybe you're gonna have this one over here, or this one over here, or this one over here. If we talk about roots, what are roots? Roots are these dots over here, that dot over there. Here this one has no dots. Okay, so roots are x-intercepts. Here there are two, here there's one, and there is no x-intercepts. So when we are determining the nature of roots, we want to know what kind of x-intercepts are we going to have. Are we going to have x-intercepts that look like this? Are we going to have an x-intercept that looks like this? Are we going to have no x-intercepts? Okay, so I'm just going to put up a random function here. Let's go f of x is equal to x squared. I'm going to make it like minus 4x, and I'm going to go with like a plus 4. Let's keep it like that. Okay, that's a random function I came up with right now. And what we are going to do is we're going to determine the nature of roots of that function. So we want to know this function here, is it going to look like this, or like this? Okay, so how we go about that is like this. Let's maybe find out what the roots are of this function. So the actual numbers, how would you find the actual numbers of this function? You would say, well, those are x-intercepts. How do you find x-intercept? Y must be 0 for us to get our x-intercept. Great. So y is 0, that's this thing. So 0 is equal to x squared minus 4x plus 4. That's easily factorized, but we're not going to factorize it for this video. For the sake of the explanation, I'm going to say we're going to go with a quadratic formula, right? X equals minus b plus minus the square root of b squared minus 4ac, right? All of this divided by your 2a. Right, so let's do that substitution. Minus b, so it's minus 4 plus minus the square root of minus 4. Remember to put this in brackets when you use this formula, squared. Minus 4, a is 1, a is 1. Let's just get that 1 there again, and c is positive 4. Right. And all of this is divided by 2a, and a is still just 1. And we see this over here. This is going to give us a 4 plus minus. That's going to be 16 minus 16. This one is interesting. Divided by 2. Okay. Then this is going to be 4 plus and minus 0. That is a 0. Square root of 0 over 2. So our one answer is 4 plus 0 divided by 2. And our other answer is 4 minus 0 over 2. Okay, so if you wanted to know the actual numbers of your x-intercepts, this is all the stuff that you would do. You would do this, and the values that you find are going to be these numbers here. But now what you noticed over here is that there are two numbers that are the same number. Okay, so then obviously it's going to look like this one because your two roots are the same root. Okay, right. So when you do all of this, you end up with either one answer, which we found now one answer because this one and this one is both one answer, or you end up with two different answers, or you end up with no answers. Okay, when do you get one answer? Like we had one answer now. When do you get one answer? You get one answer when all of this stuff, okay, let's see the stuff over here. The stuff, what did it give you? It produced a 0. If that stuff give you a 0, you end up with one answer like you do over here. Okay, so again, if that stuff equals 0, then your picture looks like this. If that stuff, right, I'm talking about the stuff here in this green thing here, green block, circle, whatever. When these things are 0, picture in the middle. If it wasn't 0, let's say it was like a 16 or something, okay, then you would have over here, you would have 4 plus 4, and over here 4 minus 4. So then you're gonna have two different answers, right? So then you would end up with this one, right? So when all of this was, this is delta, let's call it delta from now on. When delta was 0, you ended up with this picture. When delta was like a number bigger than 0, so maybe like 16 or 4, it doesn't matter, any number bigger than 0, you end up with this. And if delta is negative, you're going to end up with this. Why? Because if delta is negative, you have a negative under your root, and we know negatives under our roots are non-real numbers. Calculator says math error. Okay, so the function looks like that. Okay, all right, so what are we saying? We're saying this. We only look at delta. What is delta? Delta is this thing. Only look at delta. And if delta is 0, your function looks like that. If delta is positive, bigger than 0, the function looks like this. And if delta is negative, smaller than 0, your function would look like that. Okay, so we'll get into a question now. Let's maybe just write those things down that I've just mentioned. Okay, so let's say delta. What is delta? Delta is the thing under the root. What's under the root? B squared minus 4ac. So we're saying that if delta is 0, you have one root. When you have one root, we'll say that it is equal, or before we say equal, not wrong, before we say equal, we'll say that it's real. And we'll say equal, and we will say irrational. Right? Always three things: real, equal, rational. When delta is smaller than 0. So understand inequalities. This one over here, this is smaller, so 0. Delta is smaller than 0. That means you're going to have a non-real number. So here you'll say non-real roots. And then lastly, delta could be bigger than 0. Then you have real, unequal. So those two values are not going to be the same thing. Real, unequal. And now you have options. Maybe it's rational, maybe it's irrational. Right. So when is it rational? It's rational if delta ends up being a perfect square. What's a perfect square? That's like a, no, 2 is not a perfect square. That's like 1, because 1 times 1 is still 1. 4, because 2 times 2 is 4. 9, because 3 times 3 is 9. 16, because 4 times 4 is 16. 25, because 5 times 5, okay, I'm sure you get the picture. So if it's one of these numbers, then it's going to be rational. If it's not one of those numbers, then it's going to be irrational. Okay, so when we're gonna get into the next question in a moment. But when you want to find out whether it's gonna look like picture 1, 2, or 3, you only look at delta. What is delta? Delta is this thing under the root. This thing under the root. You only look at delta. And if delta is 0, then it's gonna be that one, which means it is the picture in the middle. If delta is a negative number, then it's going to be this one, non-real roots, the picture on the side over here. And lastly, if delta is positive, bigger than 0, it's either it's definitely going to be this picture, but then the values are going to be real, unequal, and either rational or irrational. Rational when it's perfect, when delta is a perfect square, irrational when it's not. Okay, let's get into the question.